The Su-57 program, from its inception, was intended to represent Russia's leap into the fifth-generation fighter space, a direct response to Western advancements in stealth aviation. Yet from its earliest stages, the program has been hindered by a combination of technical limitations, insufficient industrial capacity, funding constraints, and increasing external pressure from international sanctions. As of 2025, despite over 15 years of development and repeated promises of operational readiness, the Su-57 still exists more as a political and symbolic project than as a reliable, mass-produced combat aircraft. Russia's decision to move forward with the first export of the Su-57E version is a significant political signal but does not reflect a fully mature or competitive product. The export variant is based on the same airframe and design as the domestic version, with certain capabilities restricted for foreign use. However, the domestic version itself is not yet fully developed or deployed at scale. This means that the version being exported is based on a fighter that is still in transition, still evolving toward its originally stated performance goals, many of which remain unmet. Central to the Su-57's underperformance is the engine situation. The aircraft was designed with the expectation of receiving a new generation powerplant, commonly referred to as Izdeliye 30, that would provide the thrust, fuel efficiency, and thermal profile required for genuine fifth-generation performance. However, development of this engine has faced multiple delays and setbacks. Most Su-57s, including those likely being exported, are still fitted with the AL-41F1 engine, which is essentially a modified version of the engine used in the Su-35. While this engine is powerful, it lacks the specific performance characteristics necessary for sustained supersonic flight without afterburner, supercruise, and does not reduce infrared signature to the degree required for true stealth operations. The result is a fighter that cannot perform the most essential features associated with modern fifth-generation platforms. Without a reliable, next-generation engine, the Su-57 is forced to rely on interim solutions that compromise both stealth and performance. The use of older engines also raises questions about maintenance cycles, fuel efficiency, and long-term reliability, particularly in export conditions where supply chains for replacement parts and technical support may be more limited. Beyond the engine, the aircraft's stealth capabilities have been widely criticized. While the Su-57's design includes some radar-reducing features, such as internal weapons bays and angled surfaces, the overall shaping and material application fall short of the standards seen in other fifth-generation designs. The aircraft retains large, exposed engine nozzles, traditional vertical stabilizers, and surface gaps that reflect radar waves. The materials used for radar-absorbing coatings are believed to be less advanced and less durable than those used in other stealth programs. These design choices suggest that stealth was deprioritized in favor of maneuverability, speed, or cost, a compromise that significantly impacts survivability in modern high-threat environments. Operational use of the Su-57 has also been extremely limited. Though Russia has claimed that the aircraft has been tested in combat zones, including Syria and Ukraine, no credible evidence supports the idea that it has been used in high-risk airspace or complex combat scenarios. Reports indicate that when the aircraft has been used at all, it has operated from standoff positions, firing long-range weapons from behind Russian lines. This approach avoids exposing the aircraft to enemy air defenses or air-to-air threats, which implies a lack of confidence in either its stealth profile, its survivability, or both. Moreover, the extremely low number of airframes available limits any sustained operational use. With fewer than 20 believed to be in service, any loss would be strategically and politically damaging. The industrial base responsible for Su-57 production has struggled to maintain consistent output. Sanctions imposed by the United States, European Union, and other nations have cut off access to many critical components, especially microelectronics, sensors, and advanced materials. As a result, Russian manufacturers have been forced to re-engineer systems using domestic substitutes or components from less advanced suppliers. This substitution process has led to delays, reliability issues, and reduced performance in key subsystems such as avionics, radar, and flight control systems. The long-term sustainability of this approach is questionable, particularly for complex systems that require high levels of integration and miniaturization. As for the export program, the sale of the Su-57E appears motivated more by political signaling and strategic partnerships than by commercial competitiveness. Algeria, the presumed first customer, has a history of military procurement from Russia and has fewer alternatives due to political restrictions on Western weapons sales. The Su-57E represents a symbolic acquisition, intended to project technological parity with other regional powers, but does not provide Algeria with a proven, combat-ready platform. Given that Russia itself is still developing the aircraft, the export version is likely to include even more limitations in terms of engine performance, avionics, electronic warfare systems, and maintenance infrastructure. There is also the issue of scalability. A true fifth-generation fighter program requires not just a working airframe, but a fully integrated ecosystem of production, training, logistics, and sustainment. Russia's defense industry currently lacks the depth and resilience to scale Su-57 production to meet both domestic and foreign demand. Production numbers remain in the low single digits per year, far below the levels required for force-wide adoption or sustained international sales. This makes the Su-57 less attractive to potential buyers who are looking for long-term support, spare parts, and upgrades over decades of service. The gap between public messaging and operational reality is stark. Russian officials and state media have consistently described the Su-57 as a fifth-generation fighter capable of matching or exceeding the performance of Western equivalents. However, the aircraft's actual specifications, production numbers, and usage patterns suggest otherwise. Even domestic experts have acknowledged that key criteria for fifth-generation classification, such as low observability, advanced sensor fusion, and reliable supercruise, are not yet fully realized. The Su-57 export effort marks a turning point in Russia's attempt to salvage international prestige and secure defense revenue amid a stagnant economy and increasing isolation. The delivery of the Su-57E is not evidence of a mature, effective fighter program, but rather a demonstration of how geopolitical necessity can shape procurement decisions. The aircraft remains incomplete, technologically limited, and unproven in real combat. Its deployment abroad may serve strategic purposes for Russia and its partners, but it does not represent a breakthrough in military aviation. Instead, it highlights the challenges facing a defense industry struggling to maintain relevance under the weight of outdated infrastructure, disrupted supply chains, and an increasingly narrow set of international buyers.